Everything is awesome. Okay, so we're on page 36, 37. We're going to take some notes, and then I'll collect the homework, which is pages 38, 39. So it is a little bit of a review, like Jacob just mentioned. So that's leading us right into the quadratic formula. That's our big, infamous lead up to. So x squared equals 16. The main thing you want to make sure that you do is take plus minus square root of 4. When it's not a perfect square, you want to make sure that you do plus minus and then take out your perfect square, which in this case is 2 root 6. Next thing you want to remember is to isolate. Isolate means to get by itself. Get squared term by itself. And then I've got x squared equals 18. And I know this was a repeat of your homework. That's why I'm kind of going fast. Right? Is that what someone told me? That? Oh, okay. So when you subtract 17, you get 14. Divide by 2, then you get 7. Take the square root, make sure you get plus minus 7, root 7. When it's a parabola, jeepers, although these are all parabolas, but when it's a parentheses like that, you've got x plus 8 equals plus minus 11. So if it turns out to be numbers, you want to go ahead and shoot off into those two. So I've got negative 8 plus 11, which is 3, and negative 8 minus 11, which is negative 19. All right, so since the rest of these were repeat, I'm going to kind of hop up to another page, which is I'm going to hop up to page 40. So now this is page 40. And we are simplifying. Okay, so part of the reason that our quadratic formula gets really tough is because of the simplifying process, which is just sort of like basic math skills. So let me walk you through this. So this is going to be x equals 10 plus or minus the square root of 116 is going to be, remember we want to take out a perfect square. So first I'm going to start with 4, and 29 is sort of considered prime, if you will. Let's see if I can make that. Sometimes that reflection throws me. There you go. So I'm going to take out root 4 times root 29 over 6. So let me do this a step at a time. So we're going to do 10 plus or minus 2 root 29 over 6. Now, we're not quite done, and this is sort of where the Math 1, Math 2, junior high stuff that I know a lot of us missed due to COVID. So we're going to factor a 2 out of the numerator. So let me pull this out in red. Uh-oh. I'm going to take out a 2. I'm left with 5 plus or minus root 29 over 6. So now what I can factor out is the 2 with this 6. So you could either see it like that, 5 plus or minus root 29 over 3, or you could see it split up, which is 5/3 plus or minus root 29 over 3. So I'm a fan of both. I've seen this a lot of times as an answer on an ACT, SAT. I've also seen this. So what a couple of my colleagues do is from this point they split it up, which I think is a little bit easier. Then you don't have to factor first. So I'll show that on this next one, and you can see if you like it better. So x equals, so we're just simplifying, and then tomorrow we'll kind of go heavy on the quadratic formula, the whole thing. So 16 plus or minus, can I go right to 2 root 5 for this with 20? Because that's root 4, root 5. So what my colleagues do, which I might do too, so now here I had you factor out a 2 out of the numerator, but the other alternative is to split this up right away. So you're going to have 16 over 8 plus minus 2 root 5 over 8. So then you can just like deal with each one individually. 2 plus or minus root 5 over 4. Or if you factor the 2 out at this point, let me do this in green, big fat or, I could have said from this point I would have factored out a 2, 8 plus or minus root 5 over 8, and then this would go in there 4 times. But the problem with that is people want to only cancel out the 8 and the 4, but then you would have missed the root 5 over 4. So this is what I call cancelitis then, when kids just cancel that out. This has to stay together. Like when it's separated by a plus or a minus, you can't cancel over addition. So I can cancel this 2 with this 8 because it's being multiplied. All right, so the best example I can do with that is to give you just like a real simple midpoint formula. Like think of the midpoint formula, where if I said 8 plus 10 over 2, and then we know that that's 18 over 2, which is 9. If you just canceled the 2, and you're like, oh, okay, 2 goes into 8, 4, and then you would get 14. So that's what you're doing. So this is what Mrs. Buck calls cancelitis, where you're just canceling without really attaining to it. So this whole numerator is like a group that you have to keep. If I added these out and factored out a 2, no problem. Like who would do that though, right? If I did, oh, that's 18 over 2, if you factored out a 2 of that somehow, but you can't. So, oh, it's up here. So if you did that, you'd have 2 times 9 over 2, and then that would cancel, but, I mean, nobody would do that. But that's what happens, like, when this is a variable, or like this is 2 plus x over 2, kids just are like, la, la, la. But that can't happen. So that's sort of why we're spending some time simplifying it before we kind of get to the nitty-gritty. So here, like, I'm going to hop to number 4. You could, 12 plus root 21, I can't simplify root 21 divided by 3. So you could either leave it like this, or I've seen ACT answers like that, or if you split it up and said 12 over 3 plus minus root 21 over 3, then you would see the 4 plus or minus root 21 over 3. And remember, you can always check your work by checking to see if your decimals match up. So let me show you that with the groovy shading I have. Here we go. So if I said 12 plus second square root 21 divided by 3. So I'm just doing the plus version. So if I did 4 plus root 21 over 3, then that would be, that's what I do here. Oh, I took the square root of the whole thing. See how my calculator is only as good as me? Did anyone see what I did there? I took the square root of the whole thing. So, yeah, I have to arrow over. 4 plus second square root 21, arrow, divided by 3. Yay. So that's what would match up. Evil. All right. So I'll just do one more on this page, and then I'm going to go back to, or I should let you do. Why don't you want to try number 6? Sure. Are we going to factor, or are we going to split it up? Should we decide as a class what we want to do?
Split it up.
Split it up? All right. All right, so this is sort of where it gets a little bit like, if you're checking things at the board, you want to be able to recognize your answer. Otherwise, it would say -7 plus or minus root 6 over 2. So if you split it up, because that's easier for you, or then you clump it back together, but this is sort of the real part. This is actually called a complex number when you've got a real plus like an imaginary or a radical. You guys are getting tough. It's good. All right, so that is page 40. That's all I'm going to do there. So now I'm going to backpedal to... Oh, you're fine. Do I have to move it? Big fat oar. Oh, shoot. Sorry. All right, so then we're going to go, so I just added that page, 36, 37, 40 notes, and then homework I'll add probably a page in a second. All right, so now let's hop back to page 37. All right, this is a little bit of a review because what we're doing is we're solving quadratics. Now, if you recall, we spent quite a bit of first quarter finding the vertex. So this is the x-intercepts, if there are any, or the roots, or the solutions. So this is page 37. Yeah, sorry. All right, so factor each quadratic and solve for x. Complete the square to write in vertex form for problems 2 and 4. Then solve for x. All right, so the first 1 and 2, 3 and 4. I'm not going to factor 3 and 4 because the leading coefficient is not 1, but we can complete the square. So we're only going to factor these two because, and I want you to kind of bring back the leading coefficient is 1. The leading coefficient is 1. So that makes it pretty easy to factor. So remember, we're looking for factors of +6 that add up to -5. So that's going to be -2, -3. So they'll multiply out to be 6, add up to be -5. So x minus 2, x minus 3 equals 0. So this is the solving part of it. So I'm going to set x minus 2 equal to 0. So x equals 2. And x minus 3 equals 0. X equals 3. So if you recall, that means that 1, 2 is a 0, 1, 2, 3 is a 0. And this parabola is going to be The vertex is going to be down here somewhere, right in the middle of that. I mean, I could graph it and we could test it that way, but I don't want to. Okay, so x squared. Any questions there? All right. So let me go pink over here. I could graph that. I really shouldn't say I don't want to, because I want you to keep seeing. I just didn't want to wipe that off. X squared minus 5x plus 6. X squared minus 5x plus 6. Graph. Uh-oh, I'm in my stats. Zoom 6. Second quit. Zoom 6. Still in stats. Turn off stat plots. If you guys take stats a couple years from now, you'd be like, oh yeah, I remember all this. This buck would have to turn it off. All right, so here's my 2, 1, 2, and 3. So that like barely gets off the ground. So that my picture I drew over here is like almost a zoom in, which you could always do. You could always zoom in to see. Where that is. Any old do. If you can't sleep tonight, you could play around with your window. All right, number 2 is x squared plus 12x plus 20. So factors of 20 that add up to 12 are 10 and 2, both positive. So x plus 10 equals 0, so x equals negative 10. X plus 2 equals 0, x equals negative 2. I could complete the square here. I'll leave some room to complete the square. Negative 10 is over here somewhere, and negative 2 is over here. So now let's find the vertex. So completing the square, we haven't done this in a couple weeks maybe. We are going to take half of that middle term and square it. So go back up to the top here. So x squared plus 12x plus something. I was looking for my whiteout to make some more room. Make some room. I'll just use a Post-it. I want to start more to the left here so I'm not like totally make sure it's so x squared plus 12x. Half of 12 is 6. Squared is 36. Then I still have plus 20, and then I have minus 36. So remember doing this fun? So x plus 6 is what that factors into. Minus 16 equals y. So the vertex is negative 6, which you kind of knew it was in the middle here. Negative 16. So it's going to be down here. So I'm not going to show you how to keep going to solve it. I'll kind of really hit that. Well, I guess I could. All right, I will. I'll keep going to solve this. I'll just use up some more space here. So in the directions here, it says then solve for x. So I would take this. Yes, if you stop in the middle, you've got your vertex. But if you keep going, you can solve it. So if I say x plus 6 squared minus 16 equals 0, and just what we did last week, first I'm going to kick this over. So I've got x plus 6 squared equals 16. Now I'm ready to take the square root, right? So I have x plus 6 equals plus minus 4. You with me? Then what am I going to do? Minus 6. Look at all the sleepers I have. Let's see. Casper, Rayanne, Hungan, Janelli, Layla. Lots of sleepers out there. Sometimes teachers, we see it, and I'm like, do I want to wake them up? They'll see the video. So negative 6 plus 4 and negative 6 minus 4. So here comes your two shootouts. So negative 6 plus 4 is negative 2. And then the other one is negative 6 minus 4, which is negative 10. I mean, coincidence? Say no. I think not. That's right. So now you've got two ways to solve. You've got factoring, and now you've got the square roots method.
I just stick with factoring.
But the problem was, well, if it's not factorable, then you have to do that. But then, if it's not even, like, cute, but then you can do the quadratic formula. So, yeah. It's a lot. It's a lot of colada. So, do I want you to do it here? You probably wouldn't complete the square when it's like this, would you? You'd probably use quadratic formula. So, I'm not going to do these two for notes right now. So, yeah. So, when you keep solving, then you can, I'll do one of these. I just won't do this one. So first, to complete the square, I have to factor out a 2. X squared plus 1x. Oh, then that's going to be odd. I don't want to do that one. Yeah, I'm going to do this one. This one will be odd. Ick. So let's do this one. So I'm going to make myself some room here. 3x squared minus 10x plus something plus 72 minus something equals 0. Okay, you with me? So everyone remembers when I factor out that GCF, it has to come out of the middle term. Plus something. So what is that something? Half a 10? Good. Squared. Nope. Minus 3 times 25? 75. So 3 x minus 5 squared minus 3 equals 0. So right now I've got the vertex. And now I can keep solving to get to the solutions. So vertex, and then keep going to get solutions. All right, let me scoot. So that means I'm going to add 3, whee! 3x minus 5 squared equals 3. Divide through. So x minus 5 squared equals 1. When I take the square root, what happens over here? How do I get the other 1? Plus minus. So here's my shoot off. X equals 5 plus 1. X equals 6. X equals 5 minus 1. X equals 4. Sorry, I can't do that. And if you want to check it, you would graph it and say 2x squared plus 2x minus 12. Zoom 6. And here comes, oh my gosh, why is that? 3x squared minus 30x plus 72. Why are these at 2 and negative 3? 3x squared minus 10x, half of 10 is 5, squared is 25, then that's 75 minus 75 minus 3, add 3, 1, 5 plus 1, 5, you guys, why is that, did I type it in wrong? 2, oh yeah, I typed in this one. Oh my goodness, thank goodness. Thank goodness. Plus 72. I'm counting on you guys, but you just didn't do it. There's 4 and 6. Okay, I know it's a lot on a Monday morning, so thanks for sticking with me, those of you that stayed awake. So our homework, let me circle certain problems, and then I'll just kind of keep track of page 38, 39, and wait, let's see what we have for homework. Wait, 1 second. 1 second. So you are going to do page we go, 38. Okay, so that's easy enough. And then on the back, solve by completing the square. So it says solve, so that means you're just going to stop halfway, get the vertex, and then keep going. Solve by factoring, so that means you got to set it equal to 0. And then on page 40, I want you to do that one that I didn't. So I want you to do numbers 3 and numbers 5 on the homework on page 40. So homework, page 38, 39, 40, numbers 3 and 5. I'll put that on Canvas too. All right. All right. And then you guys will see this video as well if you need to watch it again or do anything. Otherwise, yay. Okay, let me just stop recording here. Stop